Hello everyone. Today my topic is about centrifugation. Let's go to the session. So, centrifugation is a laboratory technique that involves the separation of particles from a solution according to their size, their shape, density, viscosity, and buoyant density. During centrifugation, the mixture is spun rapidly, generating centrifugal force. That the force drives denser components outward, causing them to sediment at the bottom or segregate at the specific radial distance within the centrifuge container. It is widely used in various fields such as biochemistry, molecular biology, microbiology, and clinical diagnostics for tasks like isolating cells, organelles, proteins, nucleic acids, and other biological materials from complex mixtures. The principle behind the centrifugation relies on the application of centrifugal force to sediment particles as suspended in a liquid medium. When a sample is spun at a high speed in a centrifuge, the centrifugal force acts outward from the center of the rotation, causing denser particles to migrate outward and settle at the bottom of the tube or the walls depending on the type of tube, centrifuge, and rotor configuration. Conversely, lighter particles or molecules remain suspended or connected to different layers within the isolation based on their buoyant density. First is centrifugal force. The centrifugal force is the outward force experienced by an object rotating about an axis. When an object is spun rapidly at a centrifuge, centrifugal force acts on the particles within the object, pushing them away from the axis of rotation. Next, the centrifuge is a laboratory device or an industrial machine used to separate components of heterogeneous mixtures based on their density difference. It achieves this separation by rapidly spinning the mixture, causing the denser components to move away from the center of rotation more quickly than less dense components. So components of centrifugation. First is rotor. This is a component that holds the sample tubes or containers. Rotors come in various designs to accommodate different sample tube types, volumes, or centrifuge models. Some common types include fixed angle, swinging bucket, and vertical rotors. Centrifuge tube or containers, the vessels that hold the sample during the centrifugation. They can be made of various materials such as plastics or glass and come in different sizes and shapes to suit specific applications. Centrifugation machine is the main unit responsible for generating centrifugal force. It consists of motor, control panel, and the housing for rotor assemblies. So, types of rotor. So, rotors are critical component for centrifuge and they come in various types and each designed to accommodate specific sample types, volumes, and centrifugation needs. Here are some common types of centrifugation used in centrifugation. Rotors used in centrifugation. First is fixed angle. Fixed angle hold tubes at a fixed angle of 25 to 45 degrees related to the axis of rotation. The tubes are pushed diagonally to the direction of centrifugal force. They are used in molecular biology, biochemistry, and clinical laboratories. So swinging bucket rotors. These rotors hold tubes in buckets that the swing on out as a rotor accelerates, orienting the tubes perpendicular to the axis of rotations during centrifugation. They are used in fractional density gradient centrifugation and gentle pelleting and delicate samples such as organelles and viruses. Vertical rotors. Tubes vertically along the axis of rotation, allowing for efficient separation of samples based on their density gradients. It is useful in the biomolecules such as proteins, nucleic acids, and viruses. So next is types of centrifugation. There are two types: preparatory and analytical. Preparatory involves the separation and isolation of specific components from a complex mixtures for further analysis, purification, and downstream applications. It is divided into differential and density gradient. First is density differential. So differential is a method used to separate components of heterogeneous mixtures based on their differences in the size, shapes, and density. Samples are subjected to multiple rounds of centrifugation at increasing speeds. During each centrifugation step, particles with higher densities sediment faster and form in a pillar at the bottom of the tube, while lighter particles remain in the supernatant. Density next is density gradient centrifugation. The density gradient centrifugation is a technique used to separate particles or molecules based on their buoyant density in the gradient or necessary uh, increase or decrease in densities. A sample is layered on the top of the gradient medium such as sucrose or cesium chloride in a centrifuge tube. During centrifugation, the particles migrate through the gradient until they reach a position where The density matches that of the surrounding medium, resulting in their isolation at specific locations within the tube. Again, this density gradient is then divided into two common types. First is rate zonal centrifugation, next is isoperiodic centrifugation. Rate zonal are separated particles based on the sedimentation rates through a density gradient is layered on the sample is layered on to the top of the gradient, and during certification particles sediment through this gradient at rates determined by the size and shapes. Useful for separating particles with small differences in the size and shapes such as macromolecules like proteins and nucleic acids. Next is isoperiodic centrifugation. The particles separate solely based on their bion density, with the particulate migrating to the positions in the gradient where their density match that of the surrounding medium. It is achieving for technique is valuable for achieving high resolution separation of particles with small density differences such as organelles, viruses, and biomolecules. Next is analytical centrifugation. It's a technique used to analyze the properties of biological samples in a solution such as their size, shape, and mass and integration. It provides quantitative data on sedimentation rates and molecular properties and is often used for biophysical characterization and structural studies. Two main primary types of analytical centrifugation tubes are there, techniques are there. First is analytical and next is sedimentation. Analytical ultracentrifugation involves pinning a sample at very high speed at its ultracentrifugation and monitoring the sedimentation behavior of particles in a real time using optical density methods. It provides information on the sedimentation coefficient, molecular weight, sample, and stoichiometry of macromolecules in solutions. It is widely used in protein-protein interactions, protein folding, nucleic acid structures, and polymer dynamics. Next is sedimentation velocity. It measures the distribution of sedimentary particles in a sample as a function of time. It provides information on the size, distribution, and sedimentation coefficient or particles in a solution, allowing for the characterization of heterogeneous samples. So the working of centrifugation is that preparation of sample, loading the sample, centrifugation, separation, that like that. So the sample to be separated is typically prepared in a liquid medium. This could be suspension, solution, or emulsion containing particles of different densities or size. Loading the sample is carefully loaded into the containers called centrifuge tubes. These tubes are designed to withstand the force generated during the centrifugation. The loaded centrifuge tubes are placed in a rotor of the centrifuge machine. When the machine is turned on, the rotor spins rapidly, creating a centrifugal force that acts rapidly outward from the center of rotation. Separation. As the rotor spins, the denser components of the sample experience a greater centrifugal force and pushed outward towards the bottom of the centrifuge tube. Conversely, lighter components are displayed towards the top. After centrifugation, the sample is carefully removed from the centrifuge tube. The centrifugated components are now typically present in distinct layers within the tube, with the denser components like the bottom and the lighter components at the top. The separated components can be analyzed for further process or used for various applications depending on the specific goals of the centrifuge process. Next is applications of centrifuge. They are used in biotechnology and biochemistry, clinical diagnostics, microbiology, pharmaceuticals, environmental science, chemical engineering, and forensics. So that's all about my topic. Thank you so much.